Hi guys, and welcome to today's lesson of simplifying algebraic radical expressions. So we actually have done this topic before, and the only difference is we now have to do it with variables. So there are a couple properties that we talked about that you should have in your notes from when we were back at school. And I wrote them down here. I'll take pictures of them too and post them. But two properties to remember. Remember, multiplication of square roots. Remember writing this down. I remember you guys being annoyed. For every number a greater than or equal to 0 and b greater than or equal to 0, the square root of ab is equal to the square root of a times the square root of b. So that's just saying if you're taking the square root of two terms that are being multiplied together, you can take the square root of each. And I hope you remember this because we spent a really long time using this property. And the second one to remind you about is when you're dividing square roots. For every number a greater than or equal to 0 and b greater than 0, b can't be 0 in this case because remember you can't divide by 0. If you have the square root of the fraction a divided by b, you can take the square root of the numerator and the square root of the denominator. I hope this is ringing some bells. Other things I want you to keep in mind. How do you know if a radical expression is in simplest form? All three of these must be true. The radicand, that means what's under the square root, has no perfect square factors other than 1, meaning that you can't take out a perfect square. You should remember doing this. Second thing that has to happen, there's no fractions under the square root. And then the third thing is the denominator of the fraction has no root in it. And again, I'll take pictures of this and post it under the note section. So I broke this down into different videos, so this wasn't super long and you could kind of take it one step at a time. So this first video is going to be about simplifying completely. And ones that we've done before is ones like this. We might have even done the same exact example in class, but square root of 192. And so what you're trying to do is you're trying to figure out, well, what perfect square goes into 192, which is what I'm figuring out right now. So if I take 192, again, I am using my calculator right now just to find perfect squares. 64 is a perfect square. Again, this is a review question. We've already done ones like this. So I'd write 192 as the square root of 64 times 3. 64 is your perfect square. And remember, just like we reviewed, you can take the square root of each. So square root of 64 is 8, and then you can't take the square root of 3, so I leave it. So, how do I know I'm done? There's no perfect squares that go into 3, so that's my answer. Again, that's a review one. We had a whole test on that already, way back before March 13th. So how is this different? Well, here are the new types of problems. So now you have numbers and variables under the square root sign. And no, we won't be doing cube roots in this class. You'll be doing those in Algebra 2 next year. So let's look at the 45 first. I always tell people to break it up. So let's first just look at the number. So what perfect square goes into 45? I hope you're going to tell me 9. And then so 9 times 5. So that's, again, old news. So now, with the a to the 5th, we are basically looking for what, I don't know why I drew a line, but a to what power times the same a to what power equals a to the 5th. And we don't want decimals in the numerators, the exponents. So, do we know what that is? No, it would be a decimal. It would be 2.5, but we don't want that. So we need to basically rewrite a to the 5th as a to some power that you can take the square root of. And so a little trick is that if you have an odd exponent, you take that variable and write it. Oh, I shouldn't have written this A. Sorry, I'm going to take it one step. And yes, I should. I'm writing in pen. Awesome. And write it as one number less. So 5 is the number I'm looking at. It's odd. So I'm going to write the 4, because 4 is 1 less than 5. But what would this other one have to be to get 5? Think about your properties of exponents. 1. Why? Because a to the 4th times a to the 1st is a to the 5th. Remember, you add. 4 plus 1 is 5. So all I did right here is rewrite a to the 5th as a to the 4th and a to the 1st. Well, why? Why did I do that? Why didn't I do a to the third times a squared? Well, here's why. So let's go up here for a minute to my side work. Is it possible to find a to some power times a to that same power to get a to the fourth? Yes, you should tell me that is 2. A squared times a squared is a to the fourth. So that means I can take the square root of a to the fourth. So now I'm going to just go right through my radical, and I'm going to take the square root of the numbers that I can. So, great. So the square root of 9 is 3. Can I take the square root of 5? Nope. So that stays under the radical. A to the fourth. We just established that that was a squared. So an a squared goes on the outside. And can you take the square root of just a to the first? The answer is no. This is technically multiplication. So your answer is 3a squared times root 5a. You know you're done because 5 doesn't have any perfect squares that go into it, and a to the first can't be broken down anymore. Next one. Another thing I should say is that we are assuming that all variables are positive. That will change when you get to Algebra 2. I'm going to write here. Assume all variables are positive. When you get to Algebra 2, you'll have conversations about how this will differ. It's just going to be absolute values, but let's not bog ourselves down with that right now. Okay, so 27. What perfect square goes into 27? 9 times 3. N squared. Can you write n to some power times n to that same power to get n squared? The answer is yes. It's 1 and 1 because 1 plus 1 is 2. So in this case, we do not have to rewrite n squared as two different n's. All right, so here I go. The square root of 9 is 3. I can't take the square root of 3, so that stays inside. The square root of n squared is just n to the first, or n. That's your answer, 3n times root 3. Number 4, let's look at this. I am looking for a perfect square that goes into 60. And that is 4. I'm going to do 4 times 15. So here we go again. My variable is to an odd power. So remember, my trick for you was whenever you have an odd power, rewrite it as the product of two of those variables. One of them needs to be one number less than the number that you see. So 1 less than 7 is 6. And the other one needs to be 1, because 6 plus 1 is 7. This negative a on the outside is coming along for the ride. Here we go. What's the square root of 4? 2. Square root of 15? Can't do that, so that goes inside. A to the 6th. A to the what times a to the what gives you a to the 6th. Remember, it has to be the same exponent. And that's going to be 3 and 3, because 3 plus 3 is 6. So this is an a cubed. A to the first, can't take the square root of that. I need to clean up on the outside. What's a negative a times an a to the third? That's a negative a to the fourth, and we usually put the number coefficient before the variable. And then I have times root 15a. I'm done because no perfect squares go into 15 and a can't be broken down anymore. Number 5, just kidding. No numbers this time, just variables. X squared, I don't have to rewrite that because 2 is even. Y to the 5th, I'm going to rewrite as y to the 4th, y to the 1st. Remember, the trick is rewrite it to the number 1 less than the odd exponent shown, so that's 4, and then the other one has to be 1. So what's the square root of x squared? What power of x times itself will give you x squared? That's just x to the 1st. Y to the 4th. Y to the power of what times y to the power of what gives you y to the 4th? That's y squared. And then can you take the square root of just y? Nope. So square root of y stays. Number 6. What perfect squares go into 28? You're going to tell me 4 and then times 7. N squared, the 2 is even, so we don't rewrite it. The square root of 4 is 2. I cannot take the square root of 7, so that stays. The square root of n squared, Again, you're asking yourself, n to what power times that same power equals n squared? You're going to say is 1. You're done because there are no perfect squares that go into 7. So, after doing these 6 examples, you saw me every time doing this side work to figure out what is the square root of certain variables. So, there is a trick if you haven't caught on. Excuse me, when you have your even, I'm going to go back to all these and point it out to you now. Why didn't I show you that first? Well, because I wanted you to understand the topic. So, when you have the even power, you're really just dividing it by 2. So what's 4 divided by 2? 2. So you have an a squared on the outside. A to the first stays on the inside. Over here, come on and focus. You had n squared. Okay, it's even. 2 is even. What's 2 divided by 2? 1. There's your n to the first. Number 4, a to the 6th. That's your even. What's 6 divided by 2? 3. Okay, that was your 3. And then a to the first stays inside. We ended up with an a to the 4th here because we had a negative a originally on the outside. This one here, x squared. 2 divided by 2 is 1, so I have an x to the first on the outside. Y to the 4th, 4 divided by 2 is 2, y squared on the outside. And then y to the first stays on the inside. Number 6, n squared. 2 is even. 2 divided by 2 is 1. So there's that lesson.